Okay. Chaman, am I audible?
Yes, you are audible.
Okay, we'll be continuing in a few minutes. Yeah.
Okay, sure. Like, can we start without any further delay?
Okay. Hello everyone. I'm Shubhangi Khare from the Youth Project, and we are back again with the array questions. So, without any further delay, Chaman Agrawal is here with us, who will be continuing the session and guiding you all with the array questions.
So, hi guys. Uh, Today we will be extending like what we did in the previous class. In the last class, we solved around, first we saw what are arrays, and then we solved around 4 to 5 questions. So one thing I wanted to say is arrays and strings are one of the most important topics when it comes to interviews and online coding rounds. So we will be focusing more on arrays and strings. Okay, next. Is my screen visible, right?
Yeah, it's visible.
Okay, thanks. The first question I'm taking today is equilibrium point. So this question says that we have been given an array of n positive numbers. We have to find the equilibrium point. So what are equilibrium point? So equilibrium point is that point where the sum of all the elements of left side and sum of all the elements of right side are equal. We have to find such a point in our array. Okay, so let us see. So I'm taking example of this array only. Elements are 1, 3, 5, 2, 2. So we have to find such a point in our array so that the sum of all the elements in the left side and sum of all the elements of the right side are equal. Okay, let me do the indexing. Okay, if I take this point, then what is the sum of all the elements of left side? It is 1 only. Okay, left side means left of this element. Okay, that is 1. What is the sum of the elements in the right side? This is 9. So it can't be our equilibrium point. We will change our pointer. We will move one step ahead. Let us check for 5. Again, if I take sum of all the elements of left side and sum of all the elements of right side. So left sum is 4. Similarly, right sum is 4. Okay, so we will return the third position. That equilibrium point lies in the third index of my array. Okay. So there can be 2 approaches for this question. The first approach will be we can take 2 pointers, one I and j, and we can do using 2 for loops. But the time complexity will be order of n square, and that approach will be inefficient approach. So that's why I will be doing this question in a single pass in order of n time. Okay. So how will we do in a single pass? First of all, what I will do is I will calculate sum of all the elements of my array. First of all, I will calculate sum of all the elements of my array. So total sum will be 1 plus 3 plus 5, 1 plus 3, 4, 9, 11, and 13. Okay. Next. Now we will come to one by one index and we will check if the left sum is equal to right sum. Okay. So first of all, I will come to the 0th index. Okay. At this point, my left sum is 0 only because there is nothing present in the left. And the right sum is, we are taking this as 13 because 13 is the sum of all the elements of the array. Okay. Now if we are at this position, so left sum is 0 as I told, right sum is, we have to exclude this element. So excluding this element, I will say 13 minus 1. So my left sum is 0 and my right sum is 12. So this is not the equilibrium point as the left sum and right sum are not equal. Then we will move one step ahead. Okay. Now I will check if my left sum and right sum both are equal. Okay. Now what is my left sum? Left sum is plus 1, okay, the previous element, and right sum is, we have to exclude my current element. So for excluding current element, I will say minus 3. It will be 9. Okay. Are 1 and 9 equal? No. So if they are not equal, we will move again one step ahead. Okay. We will come to 5. Similarly, we will calculate again left sum and right sum. So left sum is, we have to add the element 1 plus 3, 4, and right sum is, we have to subtract the current element because right sum is 2 plus 2 and left sum is 1 plus 3. Okay, subtract the current element 5, it becomes 4 only. Okay, so at this point, my right sum and left sum both are equal. In this case, I will return the third position. First, second, and third position, I will return this position saying that this is the equilibrium point of my array. Okay, I hope it is clear. Next, we will move to the coding part. Before the coding part, let us see the input format. Input format they have given 2 is the number of test cases, 1 element, and 5 size of array and number of elements. Okay. Let us take the input first. Is equals to number of test cases. I will take n number of elements in my array. After that, I will take an array. Next, I will input all the numbers in my array. Next, we will call and we will make a function equilibrium point and we will solve there. See out. Equilibrium. I am passing my array as well as count the number of elements. My parameters are array and size of the array. So what we did first is we calculated the sum of the entire array. Then we will take one by one element of the array. Okay. So first of all, we have to calculate sum of the entire array. Then we will take a left sum and we will calculate sum at a particular point, and we will compare total sum with my left sum. Okay. So let us assume that currently sum is 0. So I got the total sum of my array. Next, we will see the left sum. Initially, left sum will be 0. And I am starting the left sum with this index. At first, we will be starting with 0th index and we will keep moving our left pointer. Okay, we are starting with this index. So at this point, there is nothing at the left. So left sum will be 0, and at the right part we will take the entire array. Okay. Now what we will do is, I will exclude my current element from the sum. Suppose we are at this index, we will exclude our current element from the sum and we will compare the left side with the right side. Excluding the current element ARR of I, and we will compare the left side and the right side. If they are equal, then we got the answer. Okay, I will return current index plus 1. If we didn't get the answer, then we will add the current element to my left sum. Okay, I will add 1 to the left sum and we will move the I pointer to this position. Okay. That's it. And they are saying if there is no equilibrium point, then we have to print -1. If there is no equilibrium point, at last I will say return -1. Okay. Let us submit and check. Okay, so all test cases are passed. If you're having any doubt, you can let me know in the chat box. Else we'll move to the next question. The next question we have taken is majority element. Okay, so they are defining majority element is the element that appears more than n/2 times. Okay, so if I take n is equals to 7, then n/2, 7/2, that will be 3. So it should occur more than 3 times. If I take n is equals to 6, 6/2, 3, it should occur more than 3 times. Okay, so we have to find an element in my array that occurs more than n/2 times. Okay, if I take this array, so here size of the array is 3 and 3 is occurring 2 times. It should occur more than 1 time, so it is occurring 2 times, so 3 is our majority element. Similarly, if we take the next array, here 2 is occurring in this array. The size of my array is 7. The element should occur more than 3 times, and 2 is occurring 4 times. So we will say that 2 is our majority element. Okay, and they have also mentioned that you can assume that array is not empty and majority element always exists in the array. Okay, so let us see how to do this question. So the first approach we have, the brute force approach, is we can again run 2 loops. We can count the occurrence of each element and then we can give our answer. But if we run 2 loops, the time complexity will be order of n squared. So we won't do like that. We will do efficiently in order of n time. Okay, so for solving this question, we will be using Moore's voting algorithm. Moore's voting algorithm. So I'm taking this array 2 to 11112. One double two. So I'm making the indices as well. 0. So according to Moore's voting algorithm, we have to assume that our first element is the majority element. We have to assume that the first element is majority element. I'm taking a variable called majority, and we will assume that the first element is majority. So what is the first element? First element is 2. So I will assume 2 is the majority element. And also I will pick a count variable. Okay. So for any variable, the count should be initially 1. If we are at 0th index, the count should be 1. Next, if we move, there are two conditions. Either the same way, the same value will be there, or we will get different value. So we have to make an if else statement. If my current element is equal to majority element, okay? If my current element is equal to majority element, then I will increase the count, obviously. Okay, we will increase the count. Else we will decrease the count. Minus. And at some point, it is also possible that at some point, what if our count becomes 0? Okay, so we can say that the previous majority element has been exhausted. We will be reassigning a new majority element. If at any point the count becomes 0, the previous majority element will get exhausted and we will be assigning a new majority element. Okay, so if the value of count is less than 1, or like it becomes 0, then we have to assign a new majority element at that case. Okay, so I will say majority is equals to current element. That's it, and we will say count is equals to 1. Let us follow this and do the coding part. First, let us explain what is this. Okay, so first I is at 0th index, majority element is 2, and count is 1. Next, I will move I one step. Next, I will move I one step, and majority element and current element both are equal. If they are equal, I will increment my count to 2. Okay, next I will move I one step. Next, majority and current element both are not equal. If they are not equal, I have to decrement the value of count. It becomes 1. Next, majority is 2, still 2, and my count is 1. I have to decrement because they are not equal. Okay, 0. Now we have discussed if count is less than 1, then my current element is exhausted, majority element is exhausted. We have to reassign in majority element. Okay, so in this case, I will reassign 1 as the majority element, and its count should be initially 1. Okay, at this point, my majority element is 1 and its count is also 1. Next, we'll move one step. So majority is 1 and my current is also 1. So I will increase the count. Okay, next we will move one step. Majority is 1, but current is 2. We will land in the else block. So I will decrement the count. Okay, again. Majority is 1 and my current element is 2. So they are not equal. Decrement the count. Now we can see that count is less than 1 or it is equal to 0. In such case, I will change the majority element. Okay, so my majority element will become equal to 2 and count will be 1. So at the last, whatever is present in the majority value, that is our final answer. Okay, if you take an example of suppose 3 3 4 4 3. Okay, if this 3 and this 4 cancels, this 3 and this 4 cancels, still we will left within 3. Okay, so count 1 is more than enough to say that this element is majority, and the question tells us that majority element always exists in our array. Okay, so same thing we will be doing in the coding part as well. Let us start with that. First of all, we'll check the size of your vector. Then I will assign a majority element, the first element of my array. I will assume that. Okay. And its count should be equal to 1. Next, we will run a loop starting from 1 because we have already used the 0th element till n I plus plus. Now we will have two cases. The current element either will be equal to majority element, either my current element will be equal to majority element or my current element will not be equal to majority element. We will have two cases. If it is equal to majority, then we will increment the count, and if it is not equal to majority, we will decrement the count. Okay. If current element is nums of I is equal to majority, then I will say count plus plus is not equal, and I will decrement the count minus minus. Now, the one thing we discussed is that if at any point my count becomes equal to 0, then we have to reassign the majority element and we have to put count is equals to 1. Okay. If at any point my count becomes equal to 0 or less than 1, we have to reassign the majority element. Majority element will be the current element and count should be equal to 1. Okay, that's it. And at the last, we will be returning the majority. Let us run and check. Okay, so all test cases are passed. So like if anyone is having doubt, you can tell me, else we'll move to the next question. Next, we will see maximum subarray. Okay, so in this question, what we have to do is we have to find a subarray with maximum sum. We have to find a subarray with maximum sum. So in this case, they have mentioned 4 minus 1 2 and 1. So what is subarray? Subarray is the continuous part in my array. Okay, so they have taken this thing, and the value is 6. So we have to find the maximum subarray sum in our array. How will we do that? We will do it using Cadaine's algorithm. Again, this is like one of the famous interview questions. We will do using Cadaine's algorithm. Okay. We have one more choice. We can generate all the subarrays. First of all, we can generate all the subarrays, but for generating all subarrays, the time complexity will be order of n cube. It will be order of n cube. So we won't do that way. You can do as well, but the time complexity is order of n cube, and you have to use 3 for loops. Okay. So that's why we'll be using Cadin's algorithm, and it will give us answer in order of n. Okay, and they have also mentioned if we can do in order of n time. Okay, so I will be using Cadin's algorithm. I'm taking a subarray. Mark the indexes as well. So we have to find a subarray with maximum sum. I will take here two variables. One is current sum, and second one is maximum sum. Like whatever maximum sum we have obtained so far. So let us assume current sum is equals to 0. And maximum sum, like we don't know what is the maximum sum. So I will take it as int min minus infinity. I will take this as int min minus infinity. First of all, I will iterate through this. First of all, I took element -4. So I will add this element in my current sum. So my current sum becomes equal to -4. Now what will happen is that we have a negative value. So further, we will have a positive value. See, there is +1 present. Okay, we will have a negative value and we will have a positive value. If I add both negative as well as positive value, what we will get a positive value if that value is larger. In case the value is suppose 7, we will get a positive value, but the quantity will be decreased. Positive quantity will be smaller. Instead of taking it as negative, I will prefer taking it as 0. Okay, I will make my current sum as 0 so that my positive quantity doesn't decrease. Okay, so my current sum is -4, but I know if I add negative with positive, I will be getting a smaller positive value. So in that case, I will be making, if the value comes negative, I will mark this as current sum is equals to 0. Okay, current sum is equals to 0. I will be moving my I pointer to the next element. Next, my current sum is equals to 1. Okay, maximum sum will also be 1 at this point. Next, we will increment I. Okay, now we are having already positive value, and positive will make a bigger positive. Okay, so if we are having two positive values, then we will increment it. Okay, so I will add 3 to the 1. 1 plus 3, it will become 4, and maximum sum is also 4 at this point. Next, I will increment my I pointer -2. So my current sum will be 4 minus 2. It will be 2 only. Okay, so I will keep this positive value because it is positive, and if we add to some other positive value, the value will increase on. Okay, so I will keep this positive value, but my maximum sum is still 4. We will not update it to 2. My maximum sum is still 4. Okay, let us move my I pointer one step ahead. Now, current sum is 2 plus 6. It will become 8. And should I update my maximum sum? Yes, because 8 is larger than 4. We will update it. Next, we will move to 2. 8 plus 2, 10. Should I update my maximum sum? Yes, because 10 is larger than 8. Next, negative 10 minus 1, 9. Should I update my maximum sum? No, because maximum sum is 10 and current sum is 9 only. So we won't update. Next, -4, 9 minus 4, 5. and I won't change my maximum sum still. Next, I is equal to -7, 5 minus 7 minus 2. Okay, so while we iterate through the array, at the end we will be getting 10 as our maximum sum, and that is my answer. So where we will get 10? We are getting 10 here, this point, right? Okay, so this is a sub array. We need to take a continuous part of the array. Okay, so I hope you understood. Let us move to the coding part now. Okay, so we will take two variables, current sum and maximum sum, and we will update maximum sum if and only if the value is larger. Okay. Let us see. Actually, my current sum is equals to 0. Current sum is equals to 0, and my maximum sum I don't know. So I will take it as minus infinity. Okay, we can represent minus infinity by infinite. Next, we will take elements one by one. So what will be the current sum? Current sum will be equal to, we will add the current value, and I will change the maximum sum if and only if it is greater than the previous maximum sum. Okay, so I will take a max of current sum and my maximum sum. If and only if the value is greater, then only we will update. Okay, next, there will be one case when my current sum will become like negative. If it becomes negative, then we will update my current sum to 0, because if we add negative to positive value, the answer we will be getting is positive, like if the value is larger, but the like quantity will be smaller for the positive value. Okay, so instead, like suppose we have -3 and 7 plus this 3, answer will be 4. We are getting positive quantity but value smaller. Instead of -3, if I take 0, 0 plus 7 is equals to 7. Okay, so if my current sum becomes negative, I will update my current sum to 0. If we will update the current sum 0. That's it. At the end, we will return the maximum sum. I hope algorithm is clear. Let us run the code. Accepted. Okay, so all the test cases have passed. So like if anyone is having any doubt, you can put it out in the chat box, else we will move to the next question. Next question we are having is jump game. Okay, so in this question we are given an array of non-negative, means positive integers, and we are placed at the first index of the array. Okay, and each element represents the maximum jump we can take from that position. Okay. Suppose we are at this position, we can take maximum of 2 jumps. We can either go to 3 or either first index or second index. Similarly, we are at 3, we can take maximum of 3 jumps and we can reach the last point. In this question, we have to tell whether we can reach the last point or not. We are at 3, we can take maximum of 3 jumps, 1 jump, 2 jump, 3 jump, and we can reach the destination. Okay, so the answer here is true. Next test case. In the next example, if we start from 3, we can take maximum of 3 jumps. If we take 3 jumps, 1 jump, 2 jump, and 3 jump, we will land at 0th position. Okay, and from 0 we can't take a jump. Similarly, if we take from 2, we can take maximum of 2 jumps from here, 1 jump, 2 jump, again we will land to 0th index. If you start from 1, maximum jump is 1 and we will stop at position 0. So output is false because we are unable to reach the last position. Okay, and as we know, we can't jump from 0th position. So in this question, we have to tell whether we can reach the destination or not. Okay, I will be taking an example. Let us take an array 1, 3, 2, 0. We are initially placed at 0th index. These are the indices. We are placed at 0th index. We are placed at 0th index. So we'll start from here. From 1, I can take only 1 jump. From 1, I can take only 1 jump. Okay. So we will update our reachable. Reachable is the maximum point where we can reach. So the maximum point is which index? 0 plus 1, first index. I will move the I pointer to next index. Here I can see maximum jump is 3. Maximum is 3. 1, 2, and 3. So we can reach at the 4th index. 4th is the last index, so we can say true. Or we can take 1 jump also, we can take 2 jump also. But maximum is 3. So what is the maximum reachable distance? That is, we are in currently first index and we can take 3 jumps. So 1 plus 3, 4. And here we can see that we can reach the last index and we can conclude that it is true because we are reaching the last index. Okay. Let us take a negative case where we can't reach this case. Three, 2, 1, 0, and 4. Okay, so these are the array elements. Again, we will be starting from the 0th index. We're starting from the 0th index and the maximum reachable value we will calculate. The reachable becomes equal to the last index and we will conclude that we can reach the last index. Okay, so currently my reachable is 0. We are present at 0th index. Okay, now from 0 we can jump 3 places, maximum 3 places. So 1, 2, and 3. We can take maximum of 3 jumps. So I will update maximum reachable distance as 3. Okay, next I will increment my I pointer to 2. Here I can see that from 2 we can take 2 jumps, maximum of 2 jumps. So again it will land me to index 3. It is already 3, so we won't update. Next, increment the I pointer to 1. From here we can take maximum of 1 jump. Okay, 1 jump will again land me to index 3. So I won't update. Next, we come to 0. From 0, we can't take a jump. From 0, we can't take a jump. And we can see that maximum reachable index is 3 only. I will increment the I pointer. As soon as the I pointer increments from the reachable distance, I will conclude that we can't reach the last index. Okay, so that was the logic behind this question. Okay, so let us take like few edge cases. What could be possible? If I say there is no zero element present in my array. If there is no zero, then we can always reach the end. Okay, so in this array we don't have any zero value, then we can easily reach the end value. And one case could be possible that we are having zero at the starting. Okay, so if we are having zero at the starting, so we can't move ahead. So in this case, we can simply return false. Okay, let us move to the coding part now. In coding part, what we will do is we will take a maximum reachable variable. Okay. First of all, int n is equals to nums.size and int my reachable variable. The maximum index we can reach. In the initially we will be pointing at 0th index. We will update as soon as we move to the next index. Okay. Now we'll be running a for loop starting from 0th index in nth index. Now what we will do? At this point, at every point we will update my reachable variable. At every point I will update my reachable variable. Okay. So initially, if I take I was at 1, so what is my reachable? Current index I plus the value. My reachable will be current index plus the value. Okay, so let us take this is 0 plus 1, 1. Again, I will increment the value of I. Now, what is the maximum reachable value? Current index 1 plus the value 3. So I can reach to the 4th index. Okay, so in this way, we will increment the reachable value. If I come here, at this point, what is the maximum reachable value? 2 plus 2, 4. It is already 4, so we are not going to update. At this point, 3 plus 0, we can't go ahead, but the maximum reachable distance is already 4, so we can easily go there. And once we reach the 4th, we can say that we got the, like, we have moved to the last part, and that's it. Like, okay, so we have to maintain a reachable variable. Reachable is equals to maximum of, how will you calculate? Current index plus the value, comma, what is the previous greatest reachable value? We have to take the maximum. And what is the false condition? If the value of I becomes greater than reachable. In this case, we have seen if value of I becomes greater than reachable, in that case, I will conclude we can't reach. Okay, let us write that part also. If I becomes greater than reachable, then we will say return false. Okay, else we will return true. Run the code and see the output. Okay. All test cases are passed. Let me submit. Okay, so the answer is accepted. So, like, if you're having any doubts or if you want me to cover any specific question in arrays, then feel free to write in the chat box. I will try to cover that in the next session. Okay, so I hope I'm clear till here. Okay, guys, that's all for today. I hope you guys like the session, and we will meet in the next class. That's all. Thank you so much. Bye-bye.
Okay, so Chaman, you have completed all the questions, right?
Yes, I have completed the
Yeah.
questions.
Okay. So thank you so much, Chaman. We'll be soon back
Thank
with
you.
some more questions on array. Okay. So signing off for the day, Shubhangi Khare from the Youth Project. And keep practicing, keep coding. Bye bye.